Come back. This is chemistry question 45 from IMAT 2017 past paper. So I'll be solving this. It says which one of the following samples of gases contain the most particles. All gases are at 0 degrees Celsius and 1 atm pressure. When 1 mole of gas has volume of 22.4 liters. So before we solve this question, we have to understand the given data provided by this question and recall the most important points. So it explicitly mentions all the gases are at 0 degrees Celsius and 1 atm pressure. So meaning the conditions that were set for this measurement are all constant. So they're fixed temperature and pressure, and also the values given for this temperature and pressure belongs to standard temperature and pressure, where the temperature is 0 degrees Celsius, or we in kelvins. In Kelvin, we say 273 Kelvin if you want to convert, and 1 atm pressure, which is almost 100 kilopascals. So this is the standard temperature and pressure. And also when 1 mole of gas has volume of 22.4 liters. So these all given data combined refers to the ideal gas law. Ideal gas law, where we know the basic general formula is a PV is equal to nRT, pressure times volume, gives the moles, the constant, and temperature. And we know we know that if we substitute the values for the moles, the gas constant, the temperature, and the pressure, like this, if we shift to that side, nRT and P, and if we just focus on the value of RT and P, this gives volume is equal to 22.4 times the moles. So this is the general formula we must know for shortcuts, so that we don't need to substitute for each values, including the R, the temperature, pressure, and everything. So we just use this shortcut so that it will make our test more easier, make easier to solving this question, because we know in IMAT generally it's very time limited, so we must use a shortcut. So this is the main formula we're going to use. Volume is equal to 22.4 times the moles. And so, yeah, this is the given data provided from the question. So what's the main rules we must recall in the relationship? So the main rule is at same temperature and pressure, the moles are proportional to the volume. So, and also we know that the number of particles are also proportional to the number of moles. So that's why we use this formula. V is equal to 22.4 times moles. But for this question specifically, we will rearrange this expression into moles is equal to 22.4 liter per mole, and volume divided by 22.4. This is the rearranged expression we're going to implement in this given options. And for the other options, we have the masses given in grams for gases. So for this case, we're going to simply use the most general formula, which is moles is equal to mass times the mol, which is in grams per moles. Since they've given us also the mass in grams for other gases, but only the two of the options given volume for the gases. So we're going to use this volume divided by 22.4 for that case. So these are the two main formula we're going to use. So now let's apply it. So for option A, so what we're given is 33.6 liter of chlorine gas. So we're going to convert this to moles since we know that the number of particles is proportional to number of moles. And to find out moles, we're going to divide volume by 22.4 if we are given with the volume for the gas molecule. So for chlorine gas, the moles equal to 33.6 liters divided by 22.4 liters per mole. So this will give us 1.5 mole. And now for option B, we have carbon dioxide gas with 66 grams. So we're going to use this basic formula. Moles is equal to mass by mR. So for carbon dioxide gas, moles is equal to the mass divided by the mR, which is 44 grams per mole, which is the molar mass for carbon dioxide molecule. So this will give us moles is equal to 1.5 mole. So this is same as the option A. So we'll ignore this both options. And for option C, it is a hydrogen gas 22.4 liters. So we're going to use this volume by 22.4 H2 gas, hydrogen gas, the moles 22.4 liters divided by 22.4 liters per mole. So this will give us 1 mole. So this is small, so we are going to also ignore this. So now option D, we have helium gas 10 grams. So we know helium gas exists as single monoatomic molecule. It does not exist as diatomic, so we have to be careful about it. So we know it's a noble gas, so exists as single atom. So the molar mass is just directly going to be 4 grams per mole. We won't multiply by 2. So moles is equal to 10 grams divided by 4 grams per mole. So this will give us moles 2.5 mole. And now for option E, we have oxygen gas with 64 grams. So oxygen gas, so 60, yes, 64 grams, sorry. So 64 grams divided by 32 grams per mole. We know oxygen exists as diatomic, so multiply 2 with 16 to get the molar mass of oxygen molecule. So the moles we'll get is 2 moles. So now we can compare which one has the highest number of particles. And since we know that number of particles is proportional to number of moles, so we don't need to multiply this with Avogadro's constant, which is 6.04 times 10 to power 23. So we don't need to do this because this will take a lot of time. So we can directly just compare. So we know that helium gas has the highest, it's 2.5, which is greater than any of other gases moles. So this is the greatest number of particles. And so we know our correct option is option D, which is the 10 grams of helium gas. So that's how we solve this question. So Thank you guys for watching my video. I hope you find this video helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.